Okay, testing out the sound. Sound okay. Let me know if you can hear my voice. There's okay, kind of I hear some noises. I think it's from the fan from my PC. It's a bit too loud. Okay, hello. Hopefully you can hear my voice. If so, let me get started. Okay, I think that's okay. So, hello everybody. This is Junichiro Horikawa, and this is the 50th episode for Houdini Algorithmic Live tutorial that I'm doing weekly. So it's almost it is in 50th. So meaning I have done it like a year so since this is a weekly tutorial. So that's a lot. Okay, and I am still planning to continue this for a while until I felt like enough. But for now, I kind of enjoyed doing this. So, yeah, I'm still gonna keep doing this for more episodes. Okay. Now, so today's episode for today's topic, what I'm going to do is the one that you're looking on a screen, and which is to create a kind of line trail morphing from one letter to another letter. Could also work for any kind of geometry, but for this example I'm going to show you how you can create this kind of a morphing effect from one letter to another letter using a text geometry. Yeah, and so this kind of things that I would like to show you using a subsolver together with some vex coding stuff. But it's not going to be that hard to understand for this one, I think. It's just a matter of organizing the structures, data structures. Right, so let's try to do this from scratch. I'm gonna keep this on the other display, and I'm gonna bring this up right here. I'm gonna open up the new editor. Okay, and let me open this one, which is the empty file. Okay, so let's do this. I have a question from DSD. How much time do you put into preparing each episode? It really depends on the stuff. For today, I didn't have much time to prepare, so I've just done it in an hour. So that's around it. But for the other episode, like the last one, I think I'd spend like 3 to 4 hours to prepare, I think. So that's kind of average, I think. 3 to 4 hours is kind of average. Today, things like today, if I don't have much time, then I have to prepare in an hour or so. Okay. So let's do this. I'm going to create a geometry node first. So the first thing I'd like to do is to create a letters that you want to morph from one to another within this frame. Okay, so I'm gonna just use the font, and you can choose any kind of font you want. So I'm gonna choose the one that I like, which is a Japanese font called Kagero, which is this one right here, which is a cool font. You can type in some kanjis like this means spring, summer, autumn, and winter in Japanese. Probably in Chinese as well. And meaning I have 4 letters right now. Okay, so what I'm gonna do, what I would like to do is to try to morph from one letter to another one by one, from the spring character spring to the summer to a autumn to winter, then go back to a spring, so that it can loop. So that's what I would like to do here. Okay, so in order to do that, I first need some attributes for this text geometry for each of the characters or letters. I mean the characters. I need to have some attributes being attached so that I know which character is in which index. Oh, hi Alexi Territorian. Thank you for the super chat. So to do that, you can check this add text attributes option here, so that going into the geometry spreadsheet for the primitive, you'll be able to see the text index and the text symbols. Now I'm only going to use this text index, which indicates which characters is at which positions. So the first primitive is 0, so I think this is all being constructed as one geometry. For the summer character, you have 1, 2, 3 indexes, same indexes, meaning I think there's 3 separate primitives for this one, probably, not sure. Let's see. Doesn't seem like so. Maybe a small maybe there are some small primitives somewhere. Well, anyway, that's it. So after you have got these attributes, currently I have too many points for these fonts, since this is a really detailed font that I'm using. I'm having like 30,000 points, which is a bit too much to use it as a guide object. So I'm going to use the resample to reduce the number of points, so that I can see until I can see the silhouette, enough silhouette. Let's see, like 0.02 looks totally fine, and the number of points become 1748. I think that's good enough. If I changed it to 10.01, doesn't change that much, so 0.02 should be fine. Okay, what if I change to 0.05? That's a bit too much. Okay, let's keep this to 0.02. Now I'm also going to make it as a extruded geometry, so that the line animation can go wrap around these characters, the extruded characters. So you could resample to a set number. Yeah. Well, the thing is that I do want to resample based on the length of the outline for each of the primitives, so kind of a reason why I use this one. Right now, poly extrude. And let's have, oops, okay. Houdini error. That was fast. Okay. So I gotta rescue this file. Seems like I have just crashed the file, so let me hopefully it won't crash again. Okay, let me also open up the cheat sheet as well, so that I can which I can refer to. Sorry. Okay, just this one. All right. So I am going to close after I have extruded. I'm going to make it as a solid object using this output back. Let me save this. Okay, looks good. Now, what I would like to do first is to create a contour for each of the letters, or for each of the characters. The same number of contours for each of the characters. The reason is because is to create a contour for each of them, and the prepare the number of contours, the same number of contours for each character, so that if you move from one character to another, you can directly go to this next contour from one to another. So that's what I would like to do, and to do that I'm going to use a for each loop to create a contour one by one using for each. And I'm going to use the for each named primitive, and then let's also check this extruded geometry. Oops. Which have text index. So I'm going to use this text index for this for each name. Instead of the name, I'm going to use text index. Okay. Now, by doing it, you'll be able to gather whole geometry based on the text index. Let's check this out. From 0, 1, 2, 3. Okay, looks good. Now, for each of the characters, what I'm gonna do is to create a contour. So to do that, I'm going to create a intersections between the grid, the plane grid, the planar grid, which is lying at the XZ plane. Let's change this to 2 by 2. Set the size to 10 by 10 is fine. So you can create intersections or contours using this grid, as well as this character geometry using a boolean. To do that, I also need to place this grid in specific positions where I want to create a contour. So let's create that point first using attribute wrangle. Put it in the second input, and let's create contour points. Okay, now what I'm gonna do, I'm first going to create get the minimum and maximum of the boundary of this characters, each of the character. So let's get that by using vector min max, and then use a function called get b box, which you can output the minimum and a maximum as an output parameter. So min from the second input, min, max. Okay. Now let's also try to get the center position of the character as well. I mean the bounding box. So you can get that using get bbox center, second input. Now, next thing I'd like to do is to determine how many contours you want for each of the characters, for all the characters. So let's create the parameter like num or contour num. You can set any numbers you want. Let's start from a small numbers, but let's set the range from 0 to 1000. Say around 200. Okay, now, and I'm going to create a for loop. To loop through the number of contours, and each iteration I'm going to create a point position from the bottom to top of these characters. Randomly pick the height from the minimum to maximum. Okay, so first of all I'm going to create a random value using random function based on the I as a seed, which indicates the number of iteration. Okay, plus some maybe a custom seed value, which you can change it by a slider. Okay, so for each iteration you get a random value from 0 to 1. Now what you want to do next is to create a random height. So random height is equal to, I'm going to use a fit 0, 1 to fit this random, which is in between 0 to 1, to min dot y to max dot y, so that the random value, which is in between 0 to 1, will be remapped in between the minimum y, or minimum height value, to the maximum height value, so that the point height should be somewhere within this boundary. Okay, so that's the height. Now for the x and z value, I'm just going to use the value from the center. So I'm going to create a new point using at point 0 set and center x for the x, and the y is for the random height, and center z for the z value. Okay, now I am going to check whether the point has been created or not. Let's see. Does it? Did it? Nope. I have to change this to detail. Yeah, now it's being created. Okay. Now, next thing I'd like to do is to set a ID for each of the point that I have just created. The ID can be just this I value, the iteration value for the for loop. So let's just do this set point attribute 0 ID pt I. Okay, and let's set this to 200 numbers. So that's easy to check. So currently I have 200 points being created, and each of the point has its ID numbers starting from 0. Now the position for the y value is random. That's not a problem. Okay. So now that I have those points, which is placed on the center of this character, but the height is random, I can use these points to move this grid using copy to points like this, which covers the characters with the grid. Now I can do the Boolean to create intersections in between these bunch of planes and the characters. So let's do that. So boolean connect this one and connect this one, and then I can say, so the first input is the grid, so let's say it's surface, and the second input is the solid object, so keep it as solid. And I would like to get the intersection, this one. All right, now I have these intersected planes, like these. And I only need the outline, so I'm going to convert this into a curve or edges using a primitive. And we're using close U to unrolled with shared points, right? So now I have these square curves, and this square curve will act as a trail path for the particle to move onto. Okay, and that's for one character. That's for the one for this winter character. Now each of the character has, it's going to do the same process inside this for each loop, so all the characters will be divided like these at the same position, at the same height, I mean. Okay, now next thing I'd like to do is to for each of the primitive that has been created using this intersected process, I would like to apply an ID for each of the primitive. And one thing you have to be careful is that some of the places you have like duplicate primitive which shares the same ID. Okay, but actually in order to morph from one character to another smoothly, it's a good idea not to share the same ID for a different primitive, but have only one ID per primitive, unique ID per primitive. So if what I would like to do here is to remove the duplicated primitive if there's any, and always keep the primitives unique in terms of the ID, so that there's only one primitive per ID. So that's what I would like to do. So now to do that, first of all, I would like to set the ID. To do that, I am going to transfer the ID from points to primitive. Now the points is at right here. No, not this one. Not this one, but the point. Okay, so these are the primitive, and let's check where these ID are. Okay, so this points have the IDs, and these planes also have these IDs on each of the points. Right. The primitive doesn't really have one. So what I could do, maybe I could use some, say, wrangle, maybe a point wrangle for this one, for these points. So for these squares, the online squares, which if you use the point wrangle, you are accessing to each of the point of these squares. And by checking the distance between these grid, which have this point ID right here, you'll be able to copy from one to another, and then since the point has its associated primitives, so you can also store the primitive attribute as well as an ID. Okay, I have a question from Dest. I wonder if you could use a line with the scatter sop to create the origin points, and I suspect you would not get overlaps because the scatter sop has a relaxation step. You could also do that, yeah. It's not a problem, yeah. You could also do the scatter points instead of this corner points to a line, probably, and apply an ID after that. But I might still need to use a point wrangle to apply an ID, so I'm just doing it once using this one. Okay. Okay. Instead of the Boolean and primitive node, did you try with the intersect node? Nope, I didn't. Does it work? Intersection analysis is the one that you were talking about. Let's see if this works. This one and this one. Well, it gives you a intersected points. Maybe that's not what I want here for now. What I wanted is this trail curve, which I can use it for the trail for the points to move on to. So maybe not this one for... Alright. So let's transfer the ID attributes from points to primitive using let's name it transfer ID. Okay. Now, first of all, since I am looking at each of the points for these squares, I'm first going to get the closest primitive to the second input, which is these grid, which have this ID attributes on the points. So let's do that. Okay, I'm gonna use a function called xyz distance. So it needs some parameters, output parameters like prim and uv, dist, and xyz dist. The second input using the current point position, and you can output the primitive number and the uv, correspond to uv. Now I can retrieve the ID value using prim uv function for the ID attribute using prim and uv that I have just retrieved using xyz distance. Alright, now let's apply this to each of the points first to check. Now let's look at the geometry spreadsheet for the point, and I'd see those ID has been transferred to each of the point of these. Okay. Alright, one thing I have to mention, previously I have said that you can use a scatter node, but you might not be able to do that after all, because I need to keep the position of each of the random points, randomly created points at the same height for each iteration. Okay, but the thing is that when you use the different characters, and each of the boundaries should have a different size, like the height. So meaning if you use the scatter node with the different height of the lines, you might I think you're gonna get a points. You do get the same number of points, but you get a different height for each of the points in each iteration. And that's going to be a problem when you want to create a morphing effects from one to another. You want to keep the index of the points and the height the same. as possible, as much as possible. And I'm keeping that height same for each iterations by using this constant feed just based on this AI value, which is based on the iteration of the for loop. So that's kind of a reason, right? Yeah, as I said, I'm using the boundary size as the base point where to create the points from minimum to maximum. So, and consider that the size of the character might changes a little bit, maybe based on the lowercase or uppercase in a alphabet, or the numbers and numerical values, or like Chinese characters like these. So based on that, I do want to get the minimum height and the maximum height to get the boundary. So I cannot just use one single like source, because if you do that, then some of the plane might miss the intersections, and you will not be able to get several planes which cannot be used for the morphing anymore. Okay, that's kind of a reason, right? So hope you got that. Now that I have applied an ID to a point, I'm also going to apply the attribute to the primitive. So primitive meaning these square lines. So first of all, I'm going to retrieve the primitive numbers from the point using point prims. Okay, p prims, maybe pt prims, then get the primitive number. Now use the setPrim attribute to apply the ID. Okay, let's check. So for the primitive, okay, nothing has been changed. Nope. Okay, some of the primitive has been applied an ID, some of it has its negative value, so I think I have done something wrong here. Let's see. Okay, this should not be primnum, but this has to be ptnum. Okay, let's check this again. Now all the primitive should have some numbers. It's good. It looks good. Right. Now the problem here is now that, as you can see, the primitive, multiple primitives shares the same IDs, and that's not really what I want. I want the number of the primitive, which is currently like 438, but I want to keep it as 200, which I have set right here, the number of points here, which indicates the number of contours. Okay, so if I have a duplicate IDs like these, I want to remove it and keep it as one unique primitive, which has only one ID. Okay, so let's think how we can do that. To do that, I am going to use the attribute wrangle again, maybe a primitive wrangle. Okay, to do that. Okay, but before doing that, first of all, well, yeah, let's just do that first. So primitive wrangle, and I'm also would like to retrieve one of the primitive, but I want to pick randomly from, like, if you have 3 duplicated IDs, I want to remove 2 of them randomly. Maybe the second one, third one, or maybe the first one and third one, or so on. I just don't want to keep the first one or the last one, because if you do that, it might give you a kind of a let's say for these ones, if you have a intersection, like intersection cut using this plane, you have the one plane on the left and one plane on the right, and if you just keep the first one, then there is a big chance that you only keep this left side and just delete all the right side, which will create a really irregular shape, which I don't really want. So I want to randomly pick the one that I want to keep, so that you have a balanced geometry, or balanced amount of numbers of curves at left and right, even if you have multiple cuts here. So that's what I would like to do here, and to do that, what I'm gonna do, let's see. First of all, I would like to retrieve the number of account number, how many same ID or same how many numbers of primitives are sharing the same ID. Like if you have, like, if the current primitive ID is equal to 0, then I would like to get the number of primitives which shares the same ID. So let's say if you are checking the primitives equal to 0, then the count that I would like to get is this 3. And you can actually do that using a function called find attriv val count function. So let's get that count sharing the same ID, find attriv val count from the first input for the primitive, an ID attribute, and ID, which is coming from the primitive ID. Okay, now let's check this out if I have got the count correctly. Let's see. For the primitive, I have just created the count, and the 0 says 3, so I think this is correct, and 1 it says 3 as well. If I look at the primitive, these are the ID which is equal to 1, and this is also 3. I mean, wait a minute. So these all 3 is 0, and these all 4. These all IDs equal to 1 is all 4, because there's 4 same IDs, so I think these are correct. Okay. Now, and I only want to remove the primitive when the count is more than 1. Okay. So I'm gonna create a condition here, and the number of primitive that I need to remove is the count minus 1. So if you have 3 same ID numbers, then the number of primitive that I want to remove is 2. 3 minus 1 equal to 2, so 4. I'm gonna use the for loop so that each for loop I can remove the primitive. Now, to be able to remove randomly, what I can do is to set the random starting numbers, okay, for each of the primitives. So let's say start. If you say it starts from 0, then you're always removing the second and third, and except for the first one. Wait a minute. Well, it also removes the first one, so it keeps the last one if you do like this. But by setting these starting index number as random, you can actually keep the random index value, which is not going to be deleted. So I'm going to use the random function based on the ID plus some custom seed value. Okay, and this will create a random value between 0 to 1, and I am going to multiply with the count so that the total number of random will be equal to a count. If it's 3, then the random value that I have just created right here with this equation is in between 0 to 3. Now by using floor, you'll be able to get the integer numbers from 0, 1, 2. I think you don't get 3 because by using random, you don't get the maximum numbers, which means 1. I think you always get the value somewhere close to 1, but a bit smaller. Okay. So that's the starting numbers, and the actual index numbers that you want to remove is start plus I, and sometimes it goes over the count numbers, so you can calculate the remains using the count so that it goes back to 0. Now, now that you have got the index, what you want to do now is to actually get the primitive number that you want to delete, okay, from this index value. To do that, you can, and this index value can be used as a ID to search for. So int del prim is equal to find attriv val 0 prim ID. Actually, I am searching for the same ID value here, okay, and the index that I'm having right here can be used with the parameter for the function called find attribute val, and the last parameter indicates which one to pick if there's more than one primitive numbers or point numbers, in this case primitive numbers, and there are multiple number of primitives, which is assured by this count number, because if it's more than 1, you have multiple numbers, more than equal or more than 2. So that means you always have a multiple numbers if you try to find the attribute value for the primitive using the same ID. And so in order to indicate which primitive to pick, you can use this which option parameter, which is for this index, which is to use this index value which is going from, if the total number of the same ID values is 3, then goes from 0, 1, 2 and go back to 0. Okay. So you can then remove prim 0 del prim 1. Okay. Now, okay, so I have deleted the primitive which is on the same plane. Now it's a bit there's a bit of emptiness on the left side and the right side. because there's a picked up from the middle side right here. But the number of primitive that I have is equal to 200 now, which is equal to the number of points here. So that's good, but I don't like the emptiness right here for this character. So maybe I would need to increase the numbers for the contours. Let's do that. So let's say around 1000. Maybe I can also change some seed value. To see if there's a good balance. Maybe I can also reduce this. 500 for now. Okay, and I can also check this for each of the characters to see the balance. Okay, so that looks okay. I can always go back to the parameter to increase more numbers. So if you want, you can go back here, but for now let's keep it as it is. Let's keep it as 500 contours. Say 500. So now you have 500 primitive. Okay, let's name this del duplicate. Okay, now I also would like to transfer the attribute from the original, right here, original input, which is these text index. Okay, because of these processes, all those attributes has been deleted at this point. So I would like to keep this text index and maybe text symbol as well to the last primitive that I'm going to output. So let's do it quickly by using attribute transfer for this one, like this. Okay, now that I have a text index and also ID. All right, now okay, I have some comments here. I think you are essentially scaling same line of points with the bounds of each character, so you could do the same things with the line, but it's not really better of anything, just another way of doing it. I think you will need to use non-equal 0 to loop over a detail wrangle rather than a primitive wrangle to always remove all but none equals 0 to loop but one curve of one ID type. Okay, well, thanks for the comment. It's always, comments are always welcome. It inspires me a lot. Right, now, where was I? The next thing I'd like to do, currently these curve that I have created, I want to use it as a running path for the points to move. Though the problem here is that I would like to move the points based on the UV value of this primitive, and normally for the curve like this kind of square curve, when you have like 4 points, if you specifically don't apply the UV by yourself, then the UV value of each of the point you get automatically is starting from 0, go to 0.25, and then 0.5, and then 0.75, even though the length is different for the depth and the width. Now that's not really what I want, because if you do that, then when the points travel to this direction, to the depth direction, which is smaller than the width, it goes really slower because in terms of UV, the distance between here and here and here and here is same, both 0.25. The direction, the distance between here, the depth is 0.25. The distance on the width side is also 0.25 in terms of UV. The automatically generated UV. But actually, what I would like to do is to move the points at the same speed for the depths and for the width. Okay, based on the length of the curve. So that's what I want to do, and to do that, you kind of need to remap or change the UV value that I have that's going to be automatically generated. So that's what I would like to do. Okay, so I can do somewhere in the last, somewhere around here. Now to do that, I'm first going to calculate the length of the curve using the measure node. Set as a parameter. Okay, so for the primitive wrangle, you get the length for each curve. Okay. Now, and I am going to use a primitive wrangle to create to go through each of the vertices from the first vertex to the last vertex using the loop and apply the UV, in this case just the U value, to each of the point. Each of the vertex. I'm going to apply the UV into the vertex instead of points because that's what you normally do in 3D geometry, I think, and that's why you get why you're going to use using a function called UV sample, I think. Probably you can also apply that to a point, but if you do it with a point, if you have only 4 points, then you can only apply 0, 0.25, 0.5, 0.75, and for the last point you cannot apply it because there's only 4 points. But if you are using vertex, then you can access to the last point as well. So 0, 1, 2, 3, 4, 5. In total, you have 5 vertex, even if the point is only 4. So for the last vertex, you can apply 1. So that's what you want to do. Now I set 0.25, 0.5, but that's not the exact value that I want to apply, but the actual UV value, the U value that I want to apply, is based on the length. Okay. Hope that makes sense. Now, let's do that. First of all, I'm going to retrieve the number of vertices using a prim vertices 0 prim num, and let's loop through all each vertex. Okay. And I'm going to get the next vertex number as well to calculate the length between the first vertex and the second vertex. Now I think when you retrieve the vertex numbers from the primitive as an array, I think the order of the points, order of the vertex is either counterclockwise or clockwise. I think it's counterclockwise probably, so going this way, or maybe that's clockwise. Cannot really see from here right now, so let's check that out later. Okay, And if you go more than the number of vertices, you have to reset to 0. So calculate the modulus like this. Okay. Right now, in order to calculate the distance, you need the point information after all. So let's also retrieve the point number from the vertex using the vertex point 0 at VT1. And retrieve the point position for each of the point. Then get the distance between those 2 points. Alright. Now, at this point, I am going to create a u value starting from 0. Okay, now the first vertex inside this loop will always have a value, the u value equal to 0. So set vertex attriv 0 uv. I'm going to use the linear vertex number, so the primitive number I can just say -1, and the VT1 is the vertex number that I want to apply the attribute to, which is this one at the I index. Okay, and the value that I want to apply is u0, 0. Now currently the u is equal to 0, starting from 0. Now in the next iteration, I want to increase the u value based on the distance value. Okay, and to do that, I can use this distance that I have just retrieved right here. Okay, so let's say float addition is equal to distance divided by f perimeter, which is the primitive's curve length, so the total curve length. So if you divide this distance from one point to the next point divided by the whole length, you can get the ratio of that length. Okay, so if this covers like 30% of the whole area or the whole curve length, then you'll get 0.3 using this calculation. Okay, and that's the value that you want to add to a u for the next iteration. And if you keep doing this for a number of vertices, the vertex u value should stop at 1 in the last. And let's check that out. So going into the geometry spreadsheet with vertex. So this is the first primitive, which have 4 vertices and goes from 0, 0.3, 0.5, 0.85, and 1. And all the primitive vertex always starts from 0 and that's 1, so I think that's correct. And the middle point always have this 5.5 because this is a square, and the depth of each side is same and the width of each side is the same, so the middle points always goes somewhere around here if you start from this point. The difference is that the depth and the width is different, so it no more have like 0.25, but instead you have like small numbers or bigger numbers. And I think these are all good. Right. Now that's the information that I wanted to create for each of the curve. Alright, looks good. Now Now, what I would like to do next is to now the example that I showed in the first shows the morphing from one character to another placed on the same positions. Now you can also just create a morph at this position, going from this position to this position, and then to this position to this position, and go back to the first one. But if you want to keep all the characters at the same positions, meaning keep it on the center of the space, the 3D space, then what you want to do, you can just move each of the characters to the center based on its boundary, or the center of the boundary, using transform. Apply it just right after it has entered the for loop. Like this, and like this. You can just say, "Hi, thank you, Adrian Water. Thank you for the comments." Yeah, it's like 50 times already. Been doing this around a year, meaning it's a lot. So moving each of the geometry to the center creates this kind of a merged geometry, right? Looks a bit busy now, but that's fine because this is just a guide geometry. Now, I have created enough information for each of the geometry, and let's see if I have enough. So I have this UV value, which is going to be used to move the points within each of the primitive, and then I have also this ID applied to each of the primitive as well as the text index. Okay, and ID at the point attribute, which I might not use. Maybe. Okay, so probably I have enough information. So let's create a solver and try to create an animation. Now, to do that, I do need to start from the initial point position, or I need to create the initial points on somewhere. Now to do that, I'm going to pick the first text index geometry, which in this case letter for the spring. So I'm going to use the delete node, and then use the filter, the group filter, to pick only the text index is equal to 1, so text index is equal to 0. Delete non-selected for the primitive, and this is the character for the spring, right? Now what I'm gonna do next is to create a scatter point, a random point to the plane, like these. Okay, now I can increase the number of points to any numbers you want, but let's start with small numbers like 2000. Okay, now I could also uncheck relax iterations to make it a bit more randomish. Does it changes? Not much. Maybe I can keep this as it is. Right. Yeah, like Dast says, I gotta save before going into the solver. I think I do get some crashes, which I did when I was creating the example as well. So finger crossed. Now let's also set some initial attributes to each of the point as well. Okay, so what I would like to do is to retrieve the initial UV from this point position. Now you can get that by point. Probably you can use the ray node, but I'm not sure if you get the same value. So what I'm gonna do, use the minimum distance, then I'll put this a prim UVW attributes. Let's set it as UV. Okay, so as a result, each of the point should have this UV or just a U value. Now there is bunch of numbers which is equal to 0, 1, so that's not good. To be able to have more randomish value, I guess I need to uncheck this reacts iteration. Now let's check this again. Now the U becomes a bit more natural, or a bit more randomish. There's no more 0, 1 anymore. So that's good. But I am not really sure yet if this value is coming from the vertex UV. So let me check this one just to make sure. I mean, you don't really need to do this, I think, but just to make sure that I'm getting the right value. I'm going to check this using a UV sample from the second input, and the attribute, string attribute name is UV, and I'm going to use the P. And what was that parameter? UV sample. Okay, right, so okay, so let's see. So I'm just going to check the first number, the first U value for the 0. So it says 0.250233 for this one. Yeah, same numbers, so it's just doing the same thing. So meaning I don't need to use the wrangle. Okay, just using the ray is fine. Alright, so this is the initial value that I would like to use to move the points. Maybe I also need some detail attribute to indicate in which index I am in during while I'm playing the frames. At each of the frame I need to morph from one character to another, meaning I'm also changing the index of the characters, the text indexes of the characters. So I need to have that information applied somewhere. I'm going to do that. I'm going to apply that value to the detail attribute. So I'm going to create an attribute, create an initial attribute for the detail. Let's name this text index for the detail as an integer starting from 0, since the first character's index is equal to 0. Alright, now I am ready, but as a guide I do need those trail curves to move the particle. So let's move this. Let's connect this to the second input of the solver, and here we go. Alright, let's move in. Now let's see. Okay, so first thing first, what are the things that I need to do now? First thing I would like to do is to separate or split the frame based on the number of texts. Okay, if you have 4 texts, I would like to split the frames into 4. So if you have like 200 frames, maybe split by 50 frames each. So 50 for the spring, other 50 for the summer, other 50 for the autumn, and the last 50 for the winter. Okay, so that's what I would like to do. And I would like to get the, if you are at the first 50 frames, I want to retrieve the spring characters and also the next target morphing characters, which is going to be a summer. So I would like to have a spring and summer laid next to each other. So to do that, first thing I'll need to do is to update the text index of the detail attribute based on the current frame, and also the maximum number of the texts. Now, do I have this max number of text currently? I don't think so. So I think I need to have that information from somewhere as well. Now I can go back to somewhere around here to retrieve the number of characters, or I can just say, you can just go back here and let's check the detail attribute. Nope. Maybe the primitive attribute. So for the primitive attribute, I have this text index and it ends at 3. So the total number of the text is equal to 3 plus 1. Maybe I can just have this last text index as a value so that I can always get the total number of the text. So what I would like to do is to use the attribute promote to get the maximum primitive attribute, which is this text index. From primitive to detail, going to retrieve the text index maximum value and change the name to max text index. Okay, as a result, you'll be able to get this detail attribute called max text index, which is equal to 3. So let's connect this to the third input right here. I guess there's a better way to retrieve that kind of information, but I'm just gonna do it like this for now. Okay, now I think I have enough information. Let's first update the text index detail attribute based on the frame. So attribute wrangle, connect this to the first input. Now change this to the detail, and from the input 3 I should have this max text index that I've just created. So I'm going to connect this one to the second input of this one, and let's say update text index. Okay, now first I am going to retrieve the max text index from the second input detail, second max text index. Alright, now I'm going to change the frame number in between, which is in between 1 to 200, into a value which is easy to use, meaning I'm going to change this in between 0 to 1. Okay, so Alt F is equal to frame. I want to start from 0, so I'm gonna subtract by 1, then divide it by an F, and let's make sure that this is a float by using 1.0. Okay, so this will create a value in between 0 to 1. Now you don't get the exact number 1 because I have subtract by 1. So the last value, when the frame reached to 200, this equations will give you a value close to 1 but just a little bit smaller, so 0.9 something. Now next thing I'd like to do is to divide this numbers, divide the 0 to 1 frame, or I mean divide the value 1 with a number of text, so that if you have a number of if you have 4 characters, then the step number that I that I would like to have here is 0.25. 1 divided by 4, so 0.25. So let's name this step F. 1 divided by a max text index plus 1, which in this case 4. So as a result, 0.25. Now I would like to use this 0.25 to divide the frame into 4 sections. Okay. Now I'm going to update the current text index by dividing the current frame, which is in between 0 to 1, by step F 0.25. Then change it as an integer, so that as a result you should be able to get the value in between 0 to 3, 0, 1, 2, 3. If the frame is close to 200, then you get the value close to 3 point something, and as a result you get 3 as an index value, an integer value. If it's close to 1 or 0, you get a text index 0. If it's in the middle, probably 1 to 2. Okay. And let's check this out. Going back and check the geometry to the detail, and if I play it, you can see that this text index is raising up by 1 for at the 25%, each 25% of the frame. So every 50 frames in this case. 50, 1, 2, 3, 0, 1, 2, 3. Alright, it's going good. Now, next thing I would like to do is to retrieve the decimal value here of this text index. I mean this equations right here. Do I say decimal? I mean the fraction. Yeah. I'm not sure if there's a function in Vex to get the fraction. Hopefully. Oh yeah, you get this. So this, yeah, this is what I would like to get. If it's 0.5, I mean if it's 1.5, but I just want to get this fraction values. I don't want the value right here, which is going to be used as an index, but just the fractional component of the float. So, and I'm going to be naming it as an F value, F attribute for the detail. So F divided by step F of this frac. Okay, let's see. So let's check this numbers again. So this numbers indicates the value within the 50 frame. Within each 50 frames, the value should go from 0 to 1 for every 50 frames. So let's check that out. Going from 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay, like that. And I'm going to use this value to indicate the morphing positions from one character to another. Okay. Alright, so now I think I have enough information. Next thing I'd like to do is to pick the, if you are at the first 50 frames, I would like to get this spring characters as the first source, and the target will be the summer character. I want to retrieve those two characters using this text index. So that's pretty easy to do. I can just use a primitive wrangle to access to every guide right here. I'm gonna create 2 of them. I'm just gonna create 1 for now, and use this detail attribute as a guide which has this text index. So I'm going to use this text index to retrieve only that value. So if, let's say, going to retrieve the index from the detail second input text index, and if the index is not equal to the current text index of the primitive, then remove that. Okay. Right. Okay, so that's what you get. And this value, this character should change based on the frames for each 50 frames, and let's check that out as well. So starting from spring, okay, no, it's not changing, is it? Nope. That is because, yeah, I think I need to, yeah, the detail, I'm missing this detail attribute, so I still gotta use this one. Yeah, I shouldn't use the merge as well. Well, I'm gonna check this by creating another one, and for the other one I'm going to retrieve the next index value. So in this case, I'm going to add index plus by 1. Now if it goes more than the maxed text index, then I have to reset it into 0, so I also need the information of the max text index, which is this one. So int max text index is equal to detail from second input max text, and I'm going to update the index by calculating the modulus by a max text index plus 1. Right, yeah, that should do the job. Now, let's see. So this should become summer character. Okay, looks good. So I think this is working. So this is going to be the source. This is going to be the target. And what you're gonna do is, within the first 50 frames, I'm going to morph from this, the source character to the target. Why am I getting the merged result? Maybe it's just a cached bug. Alright, so these are just the guide. Okay. The actual points that I would like to modify is this one, which is a bunch of points. And based on the UV value which each point has, I'm going to wait a minute. Currently, it doesn't have a UV anymore. Okay, how come? Let's see. So did I come here, and at this point there's a UV here. If I use this one, still a UV here. Okay, still a UV. Okay, well, never mind, there is a UV here. So what I'm going to do is at each step or each iteration on the solver, I'm going to update this U value, okay? And based on this updated U value, I'm going to recreate or resample, reevaluate or sample the new positions from the source and the target, and change the current point position based on that sampled position based on this U value. So that's what I'm going to do, and that's the main part of this tutorial. So I'm going to use the point wrangle, and let's just name this you move the point. Okay, now so first thing I like to do is to first of all connect those source and target like these. Now each of the point currently has its ID value like this. Okay, so based on this point ID value, I'm going to retrieve the corresponding primitive which shares the same ID from the source first. The source one has the primitive which have this ID. So I'm going to, and these are all unique. There's only one primitive per one ID here. So each of the point I would like to get that primitive numbers. And from that primitive, I'm going to resample the point position using this UV value, which is applied on the point. So in prim find attriv find attriv val. There's some problem with my microphone. Does anybody have some same problem? Can you hear me? Let me know if you can hear my voice. Can anybody hear it? Okay, well, might be due to a network speed. Well, the network speed here is, I think it's pretty fast here. I actually have like a 4,000 Mbps. Yeah, surprisingly fast. Okay, so let's continue. Where was I? So what I'm gonna do is to trying to find out the primitive numbers sharing the same ID here. So find attrib val from the second input. This primitive and ID from the point ID. Okay. Now, since I'm going to update the UV value, and each of the primitive has its different lengths, and I would like to set the speed of the point which travels around the primitive to be the same speed, or could be a random but pretty much the same. Maybe you can add the noise value later, but I want to set the speed of each of the point to be pretty much the same. So to do that, to be able to do that, I'm also going to retrieve the parameter of each of the primitive. So let's name this peri, using prim from the second input parameter, which is ranks of the primitive. Now, and I'm also right here I'm going to create a step size, how much the U value should be increased at each iteration in the solver. So let's name this move U. Okay, how much you move, how much you want to increase the U value. Now first of all, I'm going to create a length related value. Let's name this like move, and divided by the parameter of the curve, which will be converted into the U value, which actually be used to move the point. So let's set this length pretty small enough because the text is pretty small right here. It's around like 0.5 or 0.25 or something like that. So moving the points to this kind of a small speed is fine, I think. 0.01. This is going to be the length. How much points should move from one to the next iteration. Okay, thank you all for the comment. Seems like the microphone is not a big problem here. Probably. Hopefully. Alright, so the next thing I would like to do, I would also the next thing I'd like to do is to get the detail attribute from this one, which I have two attributes. One is the f value goes, the fractional value goes from 0 to 1 at each 50 frame if you have full characters. So let's get that value and use that to create a lerp or interpolation from one character to another character. So let's do that. Float f is equal to detail 0 f. Okay. Now, for now, I am going to move the current point UV x value, meaning a u value, by the move u that I've just created right here. Okay. And if it goes over 1, then you want to reset to 0. So vuv.x is equal to uv.x, or you can just get the fraction, I guess, again, frac v.uv.x. Same as calculating the modulus between this one and 1.0. Either way is fine, I think. I don't know which one is faster. I think it's just the same calculation. Okay, now that you have updated the UV value, or just the U value, you want to use this updated U value to retrieve the new point position using the UV sample from the source and the target, and using this F value to interpolate from the source to target. Okay, so position 1 for position on the source, which is this one, is going to be UV sample 1, and would like to use the primitive group filter based on this primitive number right here. So I2a prim, just converting the primitive number to a string so that you can use it as a group, primitive group. Then would like to retrieve the point position and using the UV as a guide or sample value, which is from the point UV. Now this is from the source, and I would like to get the target as well. To do that, you need to have a target primitive number which shares the same ID again. So let's get that value somewhere. Maybe I can get somewhere right here. Int t prim is equal to find attriv val 0, or no, 2, because it's connected to the third input. And then prim id I at id. Okay, so this is the primitive number from target, which is the same ID. I'm going to copy this one and just replace this to position 2 and UV sample to third input and t primitive, and just using the same UV here. Okay, now that I have two positions, position 1, which is on the source geometry, the source curve, and the position 2, which is using the same UV to get their positions on the second, the target geometry, primitive. Now I can get the final positions by using the loop function, position 1 to position 2, using f as an input interpolation value. So if the f value is 0, which is somewhere around here, if it's in between 0, 1 to 50, then you get a position 1. Now when the f becomes close to 1, which is somewhere around here, 50 frames, frame 50, then the position will be going into the summer, close to the summer. And it continues by switching. In the next 50 frames goes from the summer to autumn, and then autumn to winter, then winter to spring again. Hopefully. Oh, wait a minute. Where did it go? Where did the code that I have write? Right. Gotta write this again. Vector, position, loop, position 1, position 2, f, and update the point position with this created newly interpolated point position. Alright, let's check this out. I think I'm seeing some cache here. Let me save this and reopen this. Okay, let's see if I play it. Okay, so it goes from spring to summer for every 50 frames. Then that's not correct, is it? Nope. So it goes okay for first 50 frames, goes from the spring to summer, but after 50 frames it goes back to the spring to summer. Okay, so that is because I think I didn't update the index, or you are not getting the right index value for this one and this one. That might be the result, that might be the reason. And so let's see. So let's first check if the text index has been updated. I'm going back to this one, going into the geometry spreadsheet. Okay, so the text index has been updated, so that should be good. That should all be good. Now going back here and see. So I'm all retrieving the text in spell mistake. Text index, so that's not correct. Index. So I guess this is same. Yes, text index. Alright. So let's see. Play. So spring to summer, summer to autumn, autumn to winter, and winter to spring. Now the change is a bit too drastic. I guess it's too linear in terms of the interpolation, so let's make it a bit more, I don't know, bouncy, so that I can clearly see the original shape. The transitions are a bit too fast right now. So to do that, you can control the transition curve, maybe for this f value here. So I can use a ramp parameter, for example, to control the curve. Currently it's linear like this, but to make it a bit more smooth, or to show the original characters like spring and summer and other characters, I can create a curve like these. So it could slowly change from the spring to summer, and using only these frames to speed up the change, then goes slowly to a summer like these. Maybe I can set this pretty like this. So pretty fast on the middle like these. Let's see how it goes. Now looks a bit better, isn't it? Think so. Currently I'm creating cache here. Okay, let's toggle the real time. Alright. Looks much better. Now, the simulation seems a bit too slow here. Let's see why. Where does this performance goes? Performance monitor. Okay, let's check this out. I'm going to reset the simulations. And I'm checking which part is taking a lot of time here. So move point. Okay, this one. Okay, well, I am guessing that it always takes time when you use this primitive group. So I guess that is the problem. Yeah, this is always a problem here. So it's always better if you don't use the group, but without the group, you don't really get a good, better way. I mean, you might be able to use a prim UV, but prim UV, it seems like prim UV is based on, not based on the not based on the UV that I have applied to the vertex. Not really sure why. UV sample. So I'm using this one, but when I use this one, it makes the whole stuff drastically slow, which I don't like. Let's try to replace this with prim UV if it still works. The thing is that if you use prim UV, I think it no longer uses the point UV correctly. Currently you can see that the point is moving at the same speed, but if you use the prim UV, I think you get a different speed head based on the primitive lengths. But let's check that out. So going to a prim UV. Okay, so there's two ways to apply the UV value. One is without the primitive number, one is with the primitive number. Okay, I think, wasn't it? Running the context of node can integer present and input alternatively. The name attributed read. Well, actually, it seems like you can use the UV values. To use this, yeah, as it says here, if you want to use the UV stored at the vertex attribute, you gotta use this UV sample. But this is a bit slow. Okay, let me think if I can filter using this one to get the value that I want. Okay. So let me see if I remove this one, if it's going to be a problem or not. I think it does, but let's just see. Okay, yeah, no. No good. What if I use prim UV? What's the parameter? So prim UV, you have string attribute name. And VUV. Right. And change this to prim UV to P prim T prim V UV. Okay. Yeah, this is faster, but speed, as you can see, the point speed is different at different layers. So that's not really what I want. Okay. Yeah, it's a bit of a problem here. So it's better to use a UV sample, but slow. Faster is good, but it's not precise. That's the problem. Okay, well, I guess if you're not using it for the real-time purposes, then you can still use it. Since you're just going to render it. So I'm gonna keep it with the UV sample after all. If it's for the real-time purpose, then you might want to use prim UV, but since this is Houdini, it's not for the real-time. So let's close our eyes for that. Okay, now the speed is good for the points. The calculation speed is a bit slow, but it's okay. Alright. Okay, looks good. I got a comment. You could probably rewrite everything to blur between positions instead. Positions of... not sure. Which positions are you talking about? Well, let me know. But for now, I'm gonna go with this one, and let's also create the trail out of these points. Let's make it as a polygon, connect polygon, uncheck close rows, increase the number of, increase the length of the trail. I don't know, maybe to 10. It looks really long here. Okay. Now let's wait to have a cache while it starts. Wow. Alright, looks cool. Looks good enough. Oops. Okay. Now that looks good. The things that I'm gonna do for now is kind of a final touch here. I mean, you could do anything with it. What I could do, maybe in order to render it, I'm going to use the extrude to extrude this upward. Maybe I do need to have a normal direction going upward for the point, so I'm going to create a attribute, create. Okay, it suddenly goes really slow, not sure why. Let me reopen this one. Going too hot. Maybe. Okay. For this one, for attribute create, I'm going to create a normal attribute for the point going upward, so only the y value has 1. Right now, going to delete the font. Oops, that's too much. Wait, is this the right direction? Nope. I'm going to change this to point normal, existing. Yep. Now that's a bit too high, isn't it? Maybe a bit too high still. Yeah. So I'm going to create a strip like these. Okay. And let's color this white. Then create a normal, recreate the normal. Okay, might want to make it reversed. Okay, and let's hide out the edges. Alright, plane it. Cool. Pixelized typography, morphing from one to another. Now let's wait until it finish creating a cache, and you'll be able to see a bit more smoother effect. Goes until, wait until 200. And still a bit slow. I guess I would like to create a cache, file cache. Alright, let's see. Alright. Love it. Now I think this can be used with any characters you want, I think. Currently I'm using a Japanese characters using a Japanese font, which I like. Let's change this to something else other than like 4 characters. Could be anything. Let's also change the font. I don't know. Avenue and X bold and Houdini. How does it look like? Not bad. Okay. And since you have tons of characters now, I think you're getting more faster transitions. Let's cache this as well. And it's a bit smaller, but that's fine. Not a cache. Geo2. Okay, finger crossed. Alright, let's see if I play it from start. Nice. Yeah. Ah, well, forgot to use this cache. Okay, better. Okay, it's not bad. Might look good in the render. If someone could try this, that would be great. Alright. So that's pretty much it for today. If you want to keep the character's position as it is, like here, you can disable this one. And I think it should still work. Let's see. Let's check that as well. Hopefully it works. By the way, as always, I'm going to upload the file that I have just created right here to a GitHub, and I'm going to post a URL to the download page so that you can download the zip file to use it for your reference. Yeah, for any purpose is fine. And I'm also keep this video as an archive so that you can always rewatch it if you're interested, if you find this interesting. Okay, let's do Houdini. Okay, there's some interesting bug here. I'm not sure what this point means, what this is. Well, let's just keep that as it is. That looks cool. Alright. So, overall looks pretty good. So that's pretty much it. If you have any questions or if you have any suggestions, please let me know. If not, I would like to end the live here. If you want to, you could also change a bit of speed based. So this is the speed I'm using right now, but you can use a little bit of noise to change the speed a little bit. Oops. Going back to this one. Somewhere around here. So this is currently the speed that I'm using, but by adding some noise-based value, you could also maybe change the speed of each of the strips. Or maybe you could just use the randomness as well. Maybe using the random is fine in terms of the movement. And for the randomness, I think I can use the seed based on this ID. So each ID has different speed. So let's try to do that, shall we? I'm going to rand I at ID plus some seed value. And it's at less than this value, so going to, let's say, multiply by 1 plus rand. Yeah, should be good. So this is in between 0 to 1, and by adding 1, you have in between 1 to 2 for this speed. So you get in between 0.01 to 0.02. 0.02 might be too fast. Let's change this to 7.5. Okay, what's the error here? Switch move, multiply. We need one more parenthesis. Okay. So hopefully we'll give you a bit more interesting movement. Where is it? Oops. I'm going to change this to back to the Japanese font that I was using, which was named as Kagero. And spring, summer, autumn, and winter. 4 seasons. And let me just play the trail. Okay, that looks a bit weird. What happened? Is it due to the speed? Probably. Maybe this was too fast. Okay, now I'm going to create a cache again. Okay, well, since I think there's no questions after I have tested out this sample, I would like to finish this. Now I am, yeah. Let's see, how does it look like? Okay, I see some cache here. Okay, so I'm changing the speed of the line a bit, but doesn't look that different, is it? Well, just a subtle change. Overall, looks good, especially if you look from the three-dimensional view, perspective view, I mean. Looks good, especially when it changes from one to another, like it. Alright. And probably I could use like a little bit of rotations using a frame divided by frame end, multiply 360 degrees, multiply a number of characters, so in this case 4, and multiply by maximum angle to rotate. Squash. Alright. Looks good. Okay, so thank you very much for watching. If you like the video, please consider like the video and subscribe to the channel if you would like to see more. And the coming week I would like to do another tutorial live next week as well. And I'm also doing the Patreon, so if you are feeling kind enough to support me, that will be also great. I'll appreciate that. Okay, so thank you very much for watching, and thank you for all the comments. I really appreciate that. That will motivate me so much. Okay, and I'll upload this file soon, so please feel free to download and test it out at your environment. I'm using Houdini 8.5. Okay, thank you, and I'll see you, hopefully see you next week. Okay, goodbye, good night. Hope you have a good day. Right.